Welcome to lesson 2.7, solving proportions. Our goal for today is that we can solve and apply proportions. So let's begin by defining what a proportion is. It is an equation that states that two ratios are equal to each other. Two ratios are equal. An example of this would be A over B equals C over D. Now remember, those are variables and they just represent numbers. And a couple things we want to know is that B cannot be 0 and D cannot be 0. I believe I've mentioned this before to you that you cannot divide by 0. It's illegal in the mathematical world. And the way that this ratio is read is the following. A is to B as C is to D. So it's literally just two fractions equal to each other. That's what a proportion is. And we're going to learn a couple different methods on how to solve proportions. So in example 1, we're going to use the multiplication property that we learned within the past chapter or so. And we want to get the m by itself. So right now we're doing m divided by 12. Well, what's the opposite of divided by 12? We need to multiply by 12. And remember, when you do it to one side, you must do the same thing to the other. So the 12s cancel out because 12 divided by 12 is 1. M is by itself now, and we just need to multiply. So 12 times 7 is 84. 84 is on top, the 8 still on the bottom. Now we just need to divide, and M is equal to 10.5. So if you were to put the 10.5 in for the M, the two fractions would be equal to each other. This is using the multiplication property. Now another method is called the cross products property of a proportion. And this is basically just cross multiplying, and I'm sure you've learned this in past math classes. So this is what you want to fill in for your blanks. The cross products of a proportion are equal. An example of this is on the bottom half. 3/4 equals 9/12. The way that you solve it is you just circle the diagonals and you multiply. So we have 3 times 12 is equal to 4 times 9. And you multiply each side and you get 36 on both sides. So obviously 36 is equal to itself. And these little pieces right here, 3 times 12 is equal to 4 times 9. Those are called the cross products. All right. In example 2, we're going to use the cross multiplying process. We have 4/3 equals 8 over x. We're going to cross multiply. So we have 4 times x on one side and 3 times 8 on the other. 4 times x is 4x and 3 times 8 is 24. We have a one-step equation here and we need to divide by 4 because that's the opposite of multiplication. X is by itself now. And what does 24 divided by 4 equal? That's 6. So if you were to plug 6 in for the x above, it would work out to be the same thing as 4/3. 8 over 6 is equal to 4/3. Okay, in example 3, we're going to solve a multi-step proportion. We have b minus 8 over 5 equals b plus 3 over 4. We're going to use the same process as the previous problem, so we're going to circle the diagonals. So we have 4 times b minus 8 equals 5 times b plus 3. And as you can see, there are parentheses, so we're going to be distributing the number in front. Draw your arrows. And we're multiplying. So we have 4b minus 32. We just get that from 4 times 8. And we have on the other side 5b plus 15. Now you can see that we have like terms separated by the equals. So you could bring over the 5b to the other side, or in my opinion, I think it's easier to bring over the 4b because then we will have a positive number in front of the b. Negative 32 equals technically 1b. You don't have to write the 1. Okay, it's actually a one-step equation now. Let's subtract the 15. And we get negative 47. as our B value. So to check that, you would just plug the negative 47 in for the B in both of the positions above. When modeling a real-world situation with a proportion, you have to be careful. You have to be careful of where you put the units in particular. We need to write the proportions so that the numerators have the same units and the denominators have the same units. So an example of a correct proportion would be the following. 100 miles over 2 hours equals X miles over 5 hours. As you can see on the top, the units are the same, miles and miles, and on the bottom, hours and hours are the same. So that's what I was talking about in the middle part of this page. Now here's an incorrect example. 100 miles over 2 hours equals 5 hours over X miles. As you can see, the top are different. That doesn't work. You have to have the exact same units on top and the same units on bottom. So let's get cracking on example 4. We have, suppose the iPod Nano has 2 gigabytes of storage and can hold about 500 songs. The iPod Touch has 80 gigabytes of storage. How many songs can the iPod Touch hold? So we have a Nano and we have a Touch, and we need to compare them. So let's see our givens. 2 gigs, 500 songs. That's for the Nano. So let's label this Nano and Touch. 2 gigabytes and 500 songs. And then 80 gigabytes, wow, that's a lot more, and X songs. X is going to be the number of songs. You could really use any letter here, but X is the most common. And the easiest way to solve this is to cross multiply. As you can see, before we do so, the gigabytes are both on top, the songs are both on bottom, so our proportion is set up correctly. So let's multiply. We have 2x on one side and 500 times 80 on the other. That is equal to 40,000 on the right. That's equal to 2x. One-step equation divides both sides by 2, and you get 20,000. So on your iPod Touch, you can hold 20,000 songs, which is a ton. Okay, that completes example 4. The lesson check is remaining, but you can wait to do that until after we do similar problems together during class.